Method number 2 is partial fractions. Now it's used to rewrite complicated fractions in a way that's easier to integrate, or they're easier to handle during integration. The idea is very straightforward. So we rewrite a product in the denominator as the sum of two fractions. Okay, so this is a kind of an overly complicated way of viewing it. If you have a fraction, not necessarily in integration, but this can be used in any method. So if you have a fraction, something on top, and then on the bottom you have a function multiplied by another function. So the first function there is ax plus b, and the second one is cx plus d. So if you have something multiplied by something underneath the line, then what you can do is you can separate that or rewrite it as a term over the ax plus b plus another term over the cx plus d. I've just put those in integral form just because we're using it in integration, but the idea of partial fractions is that you can use it anywhere. So again, you're changing the product in the denominator to two separate fractions. So example 1, rewrite that as partial fractions. So we have a 1 on top, and then we have two functions. X plus 1 is the first one, and x plus 2 is the second. So I'm going to leave that fraction equal to a over x plus 1, and then plus b over x plus 2. All right, so that's the first step, and that's always going to be the first step. What we now need to do is get a common denominator on the right-hand side, which is going to be x plus 1 by x plus 2 underneath the line, like so. And then the denominators can cancel, so that means the numerators are going to be equal. So 1 will equal a times x plus 2 plus b times x plus 1. And I'll multiply them by the a and the b as well. And it gives us that. Now, I'm just shifting those up a little bit. So we're at 1 is equal to ax plus 2a plus bx plus b. The next thing you're going to do is compare the numbers left and right and compare the x's left and right. So we're starting there with comparing the x's. On the left there's no x's. On the right we have ax plus bx. Now we compare the numbers as well. On the left we have the number 1, and on the right the numbers that we have are 2 by a plus b. So the 2a and the b on the right have no x next to them, so they're just going to go with the thing that has no x next to it on the left. Alright, so that means we've got two equations. If 0 is equal to ax plus bx, then surely a is equal to minus b, and I can sub that into the bottom left hand image there where it says compare the numbers left and right, and the second line below that. And what we get then is b is equal to minus 1 and a is equal to plus 1. Now, if you remember, we tried to show that 1 over x plus 1 by x plus 2 equals a over x plus 1 plus b over x plus 2. So instead, we now have a value for the a and the b, and we just put those in. So that's our answer. So it's very straightforward. You rewrite the denominator as the product of two things. Then you leave that equal to a over the first thing and b over the second thing. And then work your way through. Eventually you'll have the top left equals the top right, and you want to compare the x's with the x's and the numbers with the numbers. So actually before that, we'll be solving it in a moment. And because we've written it as 1 over x plus 1 minus 1 over x plus 2, we'll probably have to use substitution there and that standard integral to solve it. So I'm going to do that. Here we go. So integrate y is equal to the integral of 1 over x plus 1 by x plus 2 dx. Second line, I rewrote it using partial fractions. We've already covered that. And then I just need to integrate the first one and integrate the second one. Integrating the first one, I get the natural log of x plus 1. Integrating the second, I've got a minus, so then I get natural log of x plus 2. Subtract with logs means you divide with numbers, so I can just have x plus 1 over x plus 2 there in that case. I've not given any initial conditions because I didn't want to drag out the question any further. Okay, second and final example. All right, integrate that. So we'll use partial fractions to separate out 2 over x squared plus 3x, first of all. We need to write the denominator as the product of two terms. So the denominator will be x multiplied by x plus 3. And that's the second thing there on the top line of the second image. We have 2 over x into x plus 3. Now using partial fractions, we can rewrite that as a over the first term, so a over x, plus b over the second term, b over x plus 3. The line below then, we have 2 over x into x plus 3, and what we're doing on the right is getting a common denominator. We can cancel off the denominators in that step, in which case then we get 2 is equal to a into x plus 3 plus bx, multiplying by the a, and I get that thing on the bottom right hand corner. Okay, the next step is to compare the things with just numbers in it and to compare the things with just x's in it. So the thing with the numbers, we have a 2 as a number on the left and we've got a 6a on the right. The other two terms of x is next to them, so they'll be considered separately, in which case I get a is equal to a third. And then with the x's, we've got no x's on the left, and then we have ax plus bx on the right. So we can divide an x out of both of those, we get a is equal to minus b, so b is minus a third. And then we can sub these guys in instead of the a and the b on the previous slide. Feel free to rewind the video to see what those are. But I end up getting y is equal to, actually I end up getting 1 over 3x minus 1 over 3 into x plus 3. And I need to get the integral of that. So I can take out a third as a common factor, and that leaves me with the integral of 1 over x minus 1 over x plus 3. Integrate the first term, natural log of x. Integrate the second term, natural log of x plus 3, and there's a minus between them. You'll notice as well I've put in a c there inside the brackets. And then in the last line, I multiply them by the third. So a third of the c1, I'm just going to call it big C. I don't need to put the third there because the constant is an unknown value, and we would get that value later on. Okay, that's example 2 done. Now some questions for you guys.